Alright, welcome to dimensional analysis. Let's talk about what it is. Dimensional analysis is this type of problem, a set of math, that allows us to convert from one part to another. We use conversion factors. It allows us to change from one unit to the next. So conversion factors are those ratios of equivalent values that have different units. So like 1 foot and 12 inches. If you had a piece of rope that was 1 foot long, you could also say it's 12 inches long. They mean the same thing, it's just different units to show that. 100 centimeters is 1 meter. They mean the same length of something, just different units to show it. Or 2.5 grams per milliliter is also a conversion factor, meaning if you have 2.5 grams of something, you would also have 1 milliliter of that something. So they mean the same value quantitatively, like if you held it in your hand, 2.5 grams, 1 milliliter, they mean the same value in your hand. It's just a different way of saying it, different units. Now conversion factors are really easy in the metric system. The English system is a little trickier, but luckily for us, the SI system happens to use conversion factors that are equal to the metric system. Now here's all the different units for the metric system. I don't expect you to know all of these, and actually the ones I expect you to know aren't on there. The ones I expect you to know, I have a mnemonic device for it. King Henry died by drinking chocolate milk. Not the best mnemonic device, it's kind of morbid, but I'm going to say it again. King Henry died by drinking chocolate milk. And what these words mean, this is for kilo, like kilometer. This is for hecta. This is for deca. This one is the base. Little d is for deci. Little c is for centi. And little m is for milli. So, like a base unit would simply be like a liter. You could have a kilometer, a hectometer, a decameter, a decimeter, a centimeter, a millimeter. Or something like grams would be a base. You can have a kilograms, a hectograms, a decagrams, and so on and so forth, as you can see. So really we've got liter, grams, meter, millimeter, kilometer. Those are like our base units. So if you happen to have a kilometer, that's 1,000 times bigger than the base unit, the normal meter. So each of these parts, when you move over, this is 10, 100, 1,000 difference. 10 to the 4th, 10 to the 5th, and 10 to the 6th. That's the difference between all these parts. This will come in handy on our next problem here. So when we use conversion factors, I have a set system that I like to use. We want to figure out what do we know and what do we want to know. So what do we know and what do we want to know? How can we use conversion factors to cancel out the units to go from milliliters to liters or wherever we want to go? And then in the end we want to have a check. Do we have the right sig figs? Are units good? Does our answer even make sense? Should it be this big of a number? Let's try a problem. Okay, how many centimeters are in 35 meters? This M stands for meters. You might be able to just do this in your head, and that's totally fine, but I want to show you the system using my system, because this is a simple problem, and we're going to get more complex. So let's start with, how many, question mark, centimeters? And what do we know, and what do we want to know? I want to know how many centimeters, and I know 35 meters. So how many centimeters are in 35.0 meters? What do we know? 35 meters. What do we want to know? How many centimeters? We're going to use conversion factors to figure this out. So conversion factors means multiply by a fraction. All problems have this set pattern that you see here. I want to get out of meters, so I'm going to put meters on the bottom. That way with meters on top and meters on bottom it cancels. It's kind of like if you were given a problem like this in math class. How would you simplify it? Well, you would say the 2's are on top and on bottom so I could cancel it. So really all this is equal to is 3. Same thing here. Now just make it 2 meters on top and bottom. Well, the meters still cancel, and that's why you're just left with 3. So whether it's letters or numbers, they can still cancel. So I'm out of meters, and I want to get into centimeters. So I have to ask myself, how many centimeters is there in a meter? And you may know that in your head, which would be great, but you may not. That's when you want to bring out your mnemonic device. King Henry died by drinking chocolate milk. Now my milli is right here, and my meter is my base. So to get from my meter to my millimeter, I went 1, 2, 3. Or I'll do it on the top here. 1, 2, 3. That means there's a 10 to the third difference. The 10 to the third thing always goes with the rightmost unit. So there are, oh, we're not going to milli, we're going to centa. Oh man, come on Staub, we're going to centa. Whew. So we went 1, 2, that's a 10 to the second difference. 1, 2, oh gosh. My 10 to the second will go with my right unit. So there's 10 to the second, or 100 centimeters in 1 meter. 10 to the second goes with my right unit. 1 goes with my left unit. And so that way we can use it for any part. I'll show you a more complex one on the next one. Alright, so I've got 35 meters times it by this fraction of 100 centimeters per meter. My meters cancel, so I'm left with centimeters per unit. I'll take my 35.0 meters times my 100, and I get 3500 in my calculator. So at this point I've got to ask my last parts. Sig figs. This number right here has 3 sig figs. This conversion factor right here has infinite sig figs, because you have to ask yourself, how certain are you that there's 100 centimeters in a meter? I'm super certain. I'm infinitely certain that there are 100 centimeters in a meter. All conversion factors will have infinite sig figs, which means between 3 and infinity, 3 is the smaller number, so my answer should have 3 sig figs. Right now it only has 2, but if I put a line over it, now I have 3 sig figs. 3, 5, 0 with a line over it to show the third sig fig, 0. I got units, my centimeters. Does my answer make sense? Yeah, there's a lot of centimeters in a meter. This answer is finally correct. Okay, let's try another one here. Okay, how many kilometers in 22 millimeters? Question mark, kilometers are in 22 millimeters. Alright, I'm going to times it by a fraction. I'm going to put millimeters on the bottom. That way the millimeters will cancel. And I'm going to put kilometers on top. Looking at my mnemonic device, King Henry died by drinking chocolate milk. I'm going for kilometer to millimeter. So I got to count how many over that is. 1, 2, 3, 4, 5, 6. This is 10 to the 6th difference. That's the number that goes with my right-hand part, my milli. There are 10 to the 6 millimeters and 1 kilometer. So I'm going to put 1 with kilometer, 1 with kilometer, 10 to the 6th with millimeter, 10 to the 6th with millimeter, because it's 6 over. And that's the end. I want to get from millimeters to kilometers, and I can do it in one fraction. So I'm going to push in my calculator, boop, 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 boop. 2.2 times 10 to the negative 5, I believe. I actually don't have my calculator here, but I'm pretty sure that's good. Kilometers. Taking a look at sig figs, because that's the part I'm in now. There are 2 sig figs in this number. My conversion factor has infinite sig figs, which means my answer should have 2 sig figs. And I do, I have that. Sig figs are good. I got kilometers for my units, that's good. Does the answer seem logical? Well, kilometers, this number answer right here is really small, and that makes sense, because if you have 22 millimeters, you have a very, very small amount of kilometers. My answer seems good. To the next one. This one's getting a little bit trickier, but it is using the English system, which is kind of nice. So let's try it here. Question mark feet equals 6.3 centimeters. Alright. I'm going to go like any other problem, put in a conversion factor. I'll put centimeters on the bottom. That way they'll cancel. Centimeters on top, centimeters on the bottom, they're cancel. I'm trying to get from centimeters to feet. I don't know how many centimeters are in a foot, but it did give me this hint. So I'm going to go from centimeters to inches first. Once I get into inches, I know there's 12 inches in a foot, and so then I'll be good. So I'm going to start there. In 1 inch, it says there are 2.54 centimeters. That's what they gave me right here. 2.54 centimeters in an inch. Looks good. Times it by, on the bottom I'll put inch, because I want to get out of it. And I want to get to feet, so I put that on top. Oh, what is that? There we go. And that'll get me to the end. I happen to have 12 inches in 1 foot, so that's great. Looking good. At this point, I just need to bust out my calculator, which I now have one. I got 0.21 feet. Oh, come on, thing. 0.21 feet. I punched in numbers in my calculator. I got 0.21. If you look at this, this has 2 sig figs. This number, infinite sig figs. This number, infinite sig figs, as all conversion factors have infinite sig figs. So my answer should have 2 sig figs, which it does. I also have units, and my answer makes sense. 0.21 feet, that seems to seem logical sense for 6.3 centimeters. So I'm good. That's done. I can skip that one. There is a practice problem on your Google form. So right now you should be going to the Google form. And on the Google form, the question I want you to answer is, you're traveling at 72 miles per hour. You're traveling at 72 miles per hour. How fast is this? If you are in meters per second. How fast is this if you're in meters per second? On the Google form, if you don't know certain conversion factors, get yourself from miles to meters. I kind of have that in there if you need some help. So you can see how many kilometers in a meter, and not so much that, but how many kilometers in a mile. Hopefully that'll help you out. Give this your best go. If you fail at it miserably, that's A-okay. I just want to see your best effort. All right.